Good morning.
Morning, sir.
Morning. Okay. All right. So we're back to, lectures, isn't it? Today we'll be discussing about the motor system. We have almost completed the sensory system. Some of the things that are left, behind, I would be taking in classes in subsequent, lectures. Okay. And today we are going to, begin with the motor system. You already have the knowledge of how the body perceive different types of sensations. Okay, the surrounding, be it the external or the internal surroundings, isn't it? And today we will be discussing about how the body responds to stimulus in our surroundings, or how the body uses all that information that it receives in order to produce some kind of work in the form of movements. Okay, so the motor system is actually a system that deals with that. And in today's lecture, what I'm going to discuss is basically an overview of the motor system. And in the following classes, then we will be having uh, a detailed discussions on the different parts of the motor system. So we're just going to look at the motor system from bird's eye view. Okay, and what is the purpose of having a motor system? That we all know, because we have to do works, isn't it? All types of activities and works is basically conducted by the motor system. Of course, with inputs receiving from the sensory system, all right, we're able to plan, initiate, program all types of movements. Okay, as you can see here, human by nature, is a person who performs activities, all right, involving the locomotory, you can say locomotor system, all right, and uh, which involves making various types of movements. And when you make various type of movements or performing various type of activities, you also have to assume different types of postures. Okay, so when you talk about motor, function, it's not just movement alone. It also involves, assumption of different kinds of postures, because postures are actually a form of background motor function, all right, that helps in the performance of different kinds of movements. Okay, so you can see here a person who is doing the plastering of the wall. He has to kneel down so that he can perform this function. And here people who are talking and drinking and taking a cup of tea or having a breakfast, they have to assume a sitting posture. Okay, this is a kneeling posture, this is a sitting posture. And I see when you're performing some kind of gardening activities, you also assume various type of postures, which in this case this is one posture, all right, while you're using a shovel, all right, to show the soil. Okay, and here cameraman or one who surveys, do surveys of the road and all that. See, he's assuming a different posture. All right, so we see that doing various activities, involving making movements of limbs, all right, be it distal or the proximal parts of the limbs, you have to also assume a posture that would help in that movement. Okay, so therefore postures are important for execution of movements. They form a kind of a background motor function. Okay, so when you talk of motor system, therefore we are talking about two things. One is movements and postures. These are what uh, uh, basically are the functions of the motor system. Okay, in the generation of movement, or what we call as production of movement, and assumption of postures. Okay, so motor system, the necessary components of motor controls will be something like volition, generation of movements that are voluntary, that are adaptive to accomplish goals of the organism. Okay, and you have already seen in the previous slides, where you have different, you have the human being doing different types of activities, accomplishing different goals. All right, so one has to adapt to that goal, you know, achieving that goal. Now, for the, you know, generation of movement, or for making a movement, there should be, smooth and coordinated, all right, uh, form of movement, all right. So it must be smoothened, it must be coordinated, then only it becomes a purposeful movement. So whatever we're doing to achieve a goal, all right, or an activity with a goal, that goal needs to be achieved only when we can produce a movement that is smooth and that is coordinated. All right. So motor function therefore helps in smoothing the motion and uh, motion of different, not only the muscles but then even the joints. Okay. Then proprioception is also one, you know, part of the function of the motor system. Motor system must know starting position of body part, isn't it? And that is brought about by the process of proprioception. Postural adjustment, as I've already said, constant adjustment of posture to compensate for moving of limbs, changing center of mass. So basically, we have to, we have to take the center of mass, or we call it center of gravity, into concentration, so that we adopt a stable posture for the performance of a particular movement. Okay, so these are various components, functional components of the motor system, and motor system, all right, therefore consists of a number of uh, components. Okay, that eventually leads to the production of a meaningful, target-oriented, all right, assumption of posture and execution of movement. Okay, and it involves a number of areas in the brain and spine as well. Okay, so you have the higher, uh, centers like the basal ganglia, cerebrum also taking part in the production of the motor functions. Okay, so as you can see here, it involves a number of things. The highest level is sensory motor cortex. That means involving both the somatosensory area and of course the motor cortex. Okay, then we have the basal ganglia, the cerebellum, the thalamus, because the thalamus is a relay center. It's going to relay whatever information that is processed by the basal ganglia and the cerebellum back to the motor cortex. Okay, so in this, if you look at this loop, you'll eventually come to a conclusion that the motor cortex is controlled by the basal ganglia and the cerebellum. You have this loop, isn't it? That means there are afferents coming from the motor cortex to the basal ganglia to the cerebellum, and then there are efferents that that are projected into the motor cortex via the thalamus. All right, and this speaks volume. It speaks volume that whatever movement that is planned, initiated, programmed by the motor cortex is actually being regulated by the basal ganglia and cerebellum. Modified, regulated, refined, all right, by these two important higher centers. Though they are, subcortical structures, especially basal ganglia, these are nothing but subcortical. It's a subcortical structure, which is present in the base of the, forebrain. Okay, and cerebellum, of course, is a separate structure. It's lying away from the, is behind the brainstem, lying away from the, the main brain structure. Okay, but still these are considered to be higher centers with relation to motor function, because they are, the areas that, uh, help the motor cortex to produce meaningful, purposeful, measured, and, target-oriented, movements. Okay. Without these, we will never be able to, produce a meaningful, purposeful, movement, and we'll never be able to also achieve, movement, because we'll never be able to produce, or rather, adapt a kind of a, posture that would produce these meaningful movements. So anyway, you have this circuit. Then finally, all this information that comes from all these areas goes back into the motor cortex. Motor cortex sends these into the, brainstem and into the spinal cord eventually. All right, ending in the motor neurons in the spinal cord. All right, which is the final common pathways, and then reaches the muscle fiber to produce the necessary quantum of contraction. All right, or contraction in the required or in the specified, areas of the body. Okay, and in order to produce the meaningful movement. Okay, so anyway, the final common pathway that comes out of the, out of the motor cortex, relayed by the spinal cord into the muscle fiber, basically are of two types. The lateral, we say the lateral pathway and the medial pathway. The lateral pathway consisting of the lateral corticospinal pathway, or what we call is the lateral corticospinal tract, the rubrospinal tract. These are, considered to be lateral, the lateral pathways, and they are concerned with the, production of fine skilled movements. So they, control the movements of the distal portion of the limbs. Okay, the distal parts of the limbs. Okay, like the fingers, the toes. All right, and helps us in the production of fine skilled movements. Okay, so we are able to write, we're able to paint, we're able to use the fork to eat. All right, we're able to measure the length of a, cloth piece or whatever, using these fine skilled movements. All right, using our fingers and our toes. Okay, and then you have the medial pathways. All right, generally consisting of the anterior corticospinal tract and all the other extrapyramidal tracts. Okay, like the reticulospinal tract, the tectospinal tract, the vestibulospinal tract. They're all, pathways that are involved in the control of postures. So they are actually controlling muscle in the axis of the body, lying in the axis of the body. We call them as the axial muscles. That means muscle in the trunk. All right, and the proximal muscle as well. Okay, so axial and proximal muscles. And when the proximal muscles are what muscles? They are the arms, all right, the thighs, the arms, all right, of the body, of the limbs of the body, and these are, parts of the body that are involved in the control of postures. All right, so in the production of postures that are important for the execution of uh, movements, meaningful movements. Okay, clear. So this is a kind of, this the, now you can see that this is the entire, broad circuit of the motor system. Okay, so the structures can be subcortical and cortical structures, controlling association cortex, then of course it's basal ganglia, cerebellum, thalamus. As you can see here, all these are, sending information to the basal ganglia and cerebellum, which sends back to the motor cortex, and motor cortex sends, uh, you know, uh, motor information, all right, to the motor units through the descending tracks. Okay, clear. So the role of these subcortical cortical areas are you need to initiate movement, all right. Association areas in design movement, all right. And basal ganglia, cerebellum, they refine movement, as I already said earlier. And of course, the thalamus relay, all right, the information that is coming from these higher center for motor function. And finally, come to the motor cortex, which is responsible for initiating, for planning, for programming the final execution of the desired or meaningful movement. Clear? So this is the kind of, we can say, an algorithm, for the generation of a meaningful movement. Okay, and posture. Clear? So this is the same thing which I've been, actually speaking, about in the last slides. This is again the circuit, an overview of the motor system circuit. Okay, and these are the lateral motor systems I was speaking about. The medial motor system, the lateral motor system involves fine skilled movement. These are the medial motor systems involve the generation of postures, isn't it, for execution of the desired or meaningful movements. Okay, now let us look at uh, just have a look at this area, which we call as the cerebral cortex, okay, or the motor cortex for that matter. The motor cortex basically consists of the primary motor cortex, which is lying in front of the central sulcus. So this is the central sulcus, all right, and just in front of it you have the primary motor cortex, and you see that behind the central sulcus you get the primary somatosensory cortex, which we have discussed at great length, in the when we were discussing the sensory system. Okay, but then when it comes to motor function, even the somatosensory cortex is, involved, in this motor function generation, or it is part of the loop. You can say it's a part of the loop, motor system, right? Loop of the motor system. Now you have the primary motor cortex. Then you have other areas in area 6, we call them. This is area 4, Brodmann area 4. The primary cortex is Brodmann area 4. Then you have area 6, the middle part, which is called as supplementary motor area. And the premotor cortex, the lateral part of the area 6, which is called as a premotor cortex. Okay. Then you have the area 5 and 7, which is a parietal association cortex, which is basically actually a sensory cortex, but then it is also, involving in the loop of the motor system. All right. So, and of course, these are secondary somatosensory area. All right. And when you look at these, different areas, all right, of the motor cortex, let's say the sensory motor cortex, okay, that are involved in the generation of motor functions, that means movements and postures. You'll find that the primary motor cortex is basically concerned with planning, programming, initiating of movements. Okay, the final movement, the final desired movement. Okay, and the supplementary motor area is responsible with what we call as the planning and programming of motor sequences. To make a movement, you have, a particular sequence. All right, so it needs to be sequentiated. Then only the movement becomes meaningful. Okay. The premotor cortex, on the other hand, is an area that sets the posture. Okay, it sets the posture. All right, and of course we get inputs from the somatosensory areas. You have all you have these reciprocal, reciprocal connection, rather interconnection between the somatosensory cortex and different, areas of the motor cortex. Okay, the primary motor cortex, the premotor cortex, the supplementary motor cortex. All right, there you would find that there would be, a lot of reciprocal connection. Okay, so same with the parietal association cortex, you would see the reciprocal connection. You see these arrows here, they are a representation of the reciprocal connection, okay, between these different, different parts of the motor system, okay, rather the motor cortex, okay. So as I've said earlier, premotor cortex concerns setting of posture, which is important to form as a background. It needs to, for a movement to be executed, you need a background, assumption of posture. So the background for execution of meaningful movements is assumption of posture. Understand? So this premotor cortex helps in the assumption of a posture. Okay. And we will see that, this is interconnected with all these different parts of the motor cortex. It's connected with the supplementary motor area, connected with the primary motor cortex, with the primary somatosensory cortex, with the parietal association, cortex. Okay. And as you can see, these arrows, they're all ending in the premotor cortex, which again, proves that for execution of all these meaningful movements, there is a need to, coordinate between the assumption of the right posture for the execution of the desired meaningful movement. Okay, clear? Okay, and all these information are finally sent back to the, primary. Now the I mean the an integration of all these, information. They are eventually, sent to the motor cortex. Motor cortex sends them to the basal ganglia and the cerebellum, and then you get, these areas refine the movements. Okay, like basal ganglia was, going to influence not only the, the pyramidal pyramidal track output, but then the extrapyramidal track output, and mostly the, extrapyramidal are concerned with postures, except for robospinal tract. Otherwise, the rest of extrapyramidal tracts are all concerned with postures. Okay. So anyway, basal ganglia, cerebellum, they're going to refine the movement, and you see that cerebellum even influences the rate, the force, the direction, the range of movement, all right, and coordinates these, movements and posture, okay, and eventually all that is sent, all that processed information is sent back to the primary motor cortex, which eventually execute the final movement, okay, and the final movement is then sent through the lateral motor system and the medial motor system. Understand? One will help in assumption of a posture. That means the medial motor system will help in the assumption of a posture for the required, execution of, for the execution of a required movement, and the lateral motor system will be, executing those desired meaningful movements. all right, fine skill movements. Clear? Be it eating, be it drinking, be it, singing, be it, speaking, be it, writing or painting or whatever, all right, that will be executed by the lateral motor system. But this sitting, standing, kneeling, all right, assuming a particular posture would be executed by the medial motor system. Okay, clear? And in assumption of, posture, you have, posture are of different types. You have dynamic, or what we call as the phasic dynamic, or a tonic static, all right, postures. You have postures that are useful for transient type of movement, all right, transient, which are only for a moment, all right, movement which are for a very short period of time, but that can be executed repeatedly, or some movements that will be by what we call as a dynamic type of posture, and for movements that are sustained in nature, those requires postures that are static in nature. Okay, so anyway, postures can be you know can be assumed because of the process information that is coming through the medial motor system. Okay, then you'll later learn that in the generation of postures, all right, you will see that other parts of the brains, like the midbrain, the medulla, all right, will also be involved in the generation of posture, okay, or the assumption of posture, or adapting, body adapting to different postures. All right, will involve not only these areas that we have already seen, the premotor cortex, as I've already said earlier, or the whatever coming, which is coming from the primary cortex in the generating, information through the medial motor system. But then you'll see that even the medullary centers and the medulla and the midbrain also takes part in this process, assumption of posture in different situations. That's why we get all those writing reflexes. Okay, writing reflexes, and you see the frontal eye field also, taking part in the process in assuming a particular posture, because it involves the prefrontal eye field is involved in the movement of the eyes, and movement of the eyes plays a very important role in providing information with regards to the surrounding and the assumption of the body posture. Okay, so saccadic movement, we say saccadic movement, following the surrounding, all right, on a frame by frame basis. So that is also important in the assumption of the various types of postures. Okay, like when you're jumping from the one floor to another floor, or falling, these are systems that will come into play. Okay, and then will help you eventually generate a posture and a movement that will be important for the survival of the species. Okay, clear? Everything we do is for the survival of the species. So movements and postures are designed for basically that purpose. So that we can eat, we have to plow, we have to farm, or we have to hunt, we have to gather, isn't it? We have to fight, we have to fly, and everything involves movements, and movements have to be uh, generated or produced hand in hand with the assumption of the right postures. Okay, so the body will have the ability to right itself in different situations, so that it can assume a posture that can produce meaningful movements. Am I clear? So this is what is all about the motor function. Okay, So motor division, you generally think it to be a somatic motor component only, but then it's, also having an autonomic motor component as well. Okay. So there are other motor functions that regulates not only the muscles but glands as well. Okay. Other internal organs. Okay. The heart, the lungs. Okay. So these are areas that we have already discussed. I'm not going there. And one more thing which I want to, say is about the primary cortex. We say it's important for planning, initiating, programming of, desired movements. But then it is in the primary cortex that we have the representation of the different, parts of the body. No, these are nothing but, motor neurons, that are positioned, in the different parts of the motor cortex. Okay, and all these motor neurons that eventually innervates the different parts of the body. Okay, so you'll find that over the primary motor cortex, on the lateral side, all right, the lowest part of the lateral side, you'll find uh, these parts of the body that are represented. That means are innervated: tongue, jaw, lips, face, and you find that the lip, the face area, the head area, head area as a whole has a very large representation. Okay, very large, probably not only the head, the face, but then you'll find that the toes, the feet, these distal limbs, all right, these also are the trunk, all right, these are represented in a very big way. Okay, why? Because they're important in the production of movement and assumption of postures, and as well as this, which is important in the production of, articulation of, language, and, and of course other things. Okay, so the digits, the thumbs, and the shoulder, the head. This is how, the body is represented in the primary motor cortex. And this type of representation, or sometimes called as somatotropic map. Okay, this is called as the motor homunculus. We have seen a similar thing like this in the sensory system as well. Representation of different parts of the body in the somatosensory cortex, isn't it? Area 312, isn't it? So same thing we find, in the primary cortex. Not this is nothing but, is about the, neurons, all right, that originate from these areas and then end on those organs. So all the neurons in this area that I'm pointing, that innervates the face or represent the face, they are going to end on the face, all right, and the different parts of the face. Clear? And they're going to control the functions of the face. Clear? So when you look at the motor homunculus, and the human, structure is represented in this way. This is how the primary motor cortex look at the human body. Understand? How it appears to the motor cortex. This is how the human body appears to the primary motor cortex. Clear? So, motor system therefore consists of the motor cortex, which consists of the primary motor cortex, the premotor cortex, the supplementary motor cortex, the somatosensory motor cortex, the parietal cortex, posterior parietal cortex, isn't it? These are all involved in the generation of the motor functions. Okay, and all that is being the motor output, or rather, generated by, the integration and the processing that is taking place in these different areas of the cortex, will finally be transmitted to the effector through the upper motor neuron, which is originating in the motor cortex, the primary motor cortex, all right, and then relate to the lower motor neuron, which will then, this is the lower motor neuron, all right, and which will then end in the effector, which is the skeletal muscle, and eventually producing the required contraction, measured contraction, all right, resulting in the production of a meaningful movement. Okay, Am I clear? So this is an overview of the motor. Okay, clear? No one
Yes,
is saying
sir.
anything. Okay. Henceforth, we will be, discussing about the different parts of the this motor system, the different components of the motor system in detail. All right. Okay. So we will be starting with the tracks first. This is actually the final part component of the motor system, but then we are going to start with this, the tracks, consisting of the upper motor neuron and the lower motor neuron. That's called as the descending tracks. Why? Because they originate in the primary motor cortex and end or rather terminate in the muscle. Okay, clear? So it's made up of two neurons. One is the upper motor neuron and the other is the lower motor neuron. Fine. So this comprises of the broad, structure of the uh, descending tracks. Okay, general structure of the descending tracks. Okay, am I clear?
Yes, sir.
Okay, fine. Any question?
No, sir.
Okay, so now what is important for you is that you look, you see or go through your textbook and read about this, overview of the motor system. Okay, you just flip the pages and see what are the chapters that concerns the motor system. Then that gives you an overview of the entire motor system. Clear? Am I clear? Or you just read the headlines, or the, let's say, the outlines here of the motor system. Am I clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
All right, goodbye. Have a nice day.
Thank you,
Bye.
sir.